All right. Today we're going to look at transformations. We're going to start a unit on transformations. There are a lot of different types of transformations. The first vocabulary word that we have is isometry. And isometry is a transformation that preserves congruence. Okay? So it retains its shape and size. It just moves to a different location. Okay? So the only, no, I don't think we did any transformations already. Have we? Okay, I don't think we did. Let's just look at what we're doing today. So today we're doing translations. When you were in middle school, you did translations and your teacher called them slides. They're just where whatever you have moves horizontally and vertically. Okay? All right. So the most important part of what we're going to be looking at is what's called coordinate notation. And if I ask you to describe the transformation or the translation in coordinate notation, it has to be written in this format. Okay? So this is the original point, and this is how the point was moved. So if you look at your example right here, it says for this translation, we're going to take every point and we're going to move it right 3 and we're going to move it down 4. So remember when we say right 3, that is the X in this direction. When we say down 4, that is in the Y direction this way. Okay? So when you write the notation, you're using that same reference of X and Y. So right 3 goes in the X positive 3 direction. And when it says Y minus 4, it says I'm going to go in the Y direction negative 4. That's where each of those notations come from. Okay? All right. So let's take a look. We're going to take the words and we're going to write them in coordinate notation. Okay? So when it says right 3, right is an X direction to the positive. Okay? Because here's my coordinate. X, positive's to the right, negative is to the left. The Y-axis, positive is up, negative is down. So right 3 is in the X direction positive, up 2 is in the Y direction positive. So when I write my coordinate notation, I'm going to say X, Y, every single point is going to move X plus 3, Y plus 2. That's the complete coordinate notation. Okay. So let's look at the next one. So we're going to begin coordinate notation. Okay. Left. That's an X in the negative direction. So X minus 3. Down. That's a Y negative direction. Y minus 2. Good? All right. Number 3, every point moves one unit down, no, right 1 unit, down 5 units. So we've got XY moves right 1 unit. Right is an X positive direction. Down 5, down is a Y negative direction. All right, number 4 and 5 have something just a little different, so pay close attention to how I'm going to write it. So we've got XY moves. Left is in the X direction. So X direction, left is negative. So X minus 6. Does it say anything about the Y? No. Does the Y just disappear? No, I still have to account for the Y, so I just put Y it does no change, so it just stays whatever it was, it's still the same. Okay, so look here, it's going to be similar, they're just going to be traded. So we've got xy becomes up 7. So up is the y positive direction. So put it where the y belongs, y plus 7. Nothing happens to the x, so it's still just x. That is coordinate notation. You need to be able to write coordinate notation, and you need to be able to graph by reading coordinate notation. Okay? All right. Let's take a look at we're just doing translations and reflections today. So reflections, okay? So a reflection is a mirror image of a figure across a line of reflection. Each point of a reflected image is the same distance from the line of reflection as the corresponding point of the original figure. Okay. So before we look at the rule, I just want to talk about what it means to be a reflection, how you can draw it by just looking at the graph. So I'm going to reflect this polygon, HJKL, across the x-axis. This is important. You have to know what you're reflecting across. I always circle mine so that I don't lose track of what I'm supposed to be doing. I'm going to highlight that x-axis. That's what I'm going to reflect across. Okay, so if K is 1 unit above the reflection line, K prime is one unit below. If J is 3 units above, J prime is 3 units below. L is 1 above, L prime is 1 below. H is 1, 2, 3, 4, 5 above, H prime is 5 below. Oops. All right, so this is my image, my reflection across the x-axis. Okay? But there is a rule, and these rules can be really helpful. This rule says whatever the original point is, the reflected point has the same A and the opposite B. Okay? Doesn't mean this will always be negative. It means it will always be the opposite sign of the original. So let's look at how we would have done this using the rule. So if I'm going to go ahead and take H, I'm going to say H is 1, 2, 3, 4, negative 4, 5. So based on the rule, H prime, look at what the rule says, the A is the same, the B is the opposite sign. So instead of a positive 5, it's a negative 5. And if we check our graph, that's exactly where we put it. Okay, let's do another example, okay? K. K is at 1, 2, 3, 1. So based on the rule, K prime, the A stays the same, and the B changes sign. Okay? All right, so that's the rule for reflecting across the x-axis, across the x-axis. The x stayed the same, the y changed signs. Here's our rule for reflecting across the y-axis. The y stays the same, and the x changes sign. So let's go ahead and list A, B, and C, and we're going to go ahead and reflect this across the y-axis using the rule instead of counting. Move over. All right. So A is 1, 2, 3, 4. 1, 2, 3, 4. B is 4, negative 1. And C is 1, negative 2. All right. So the rule says the first value changes sign. So let's go ahead and mark A prime, B prime, C prime. The first changes sign, the second one stays the same. The first changes sign, the second one stays the same. The first changes sign, the second one stays the same. Now I can graph the reflection using my points. -4, 4. That's A prime. Make sure you label your points and your primes. B prime is -4, -1. And C prime is -1, -2. All right. So back up to this original word, isometry. Okay. Both of these transformations are isometries. That means when you do the transformation, it has to still be the same shape and same size. If something happened and when you're done it's not the same shape or it's not the same size, you've made a mistake and you need to go back and check. Okay? So when we look at, say, our reflection examples, these are still the same shape, the same size, they just have a different orientation. Okay? Same shape, same size. C is 1 to the right, so C prime is 1 to the left. B is 4 to the right, so B prime is 4 to the left. Okay? All right. So those are the rules for reflecting across the x-axis and the y-axis. Okay? You can use the rule or you can count. I think for both of these, either one is useful. Okay? There are some situations where I'm going to have you reflect across other lines, and the rules won't apply to these. You have to just count. You have to just use your skills, right? The biggest part I see students having trouble with is graphing the line that they're going to reflect across. If you don't graph the line, you cannot reflect across it. So when I look at these instructions, I'm going to graph, actually I should probably say I'm going to reflect triangle ABC across the line x equals 1. So remember, the line x equals 1 crosses x at 1. This is the line. So now my reflection, A is 2 to the right, so A prime is 2 to the left. B is 1, 2, 3, 4 to the right. B prime is 1, 2, 3, 4 to the left. Okay, make sure when you count carefully. Okay, C is 1, 2, 3, 4, 5, 6 to the right. So C prime is going to be 1, 2, 3, 4, 5, 6 to the left. When I connect my dots, I should have an isometry. Same shape, same size. Okay? So where would we graph the line y equals -2? Horizontal or vertical? Okay, y equals -2. So here's y at -2, and this is going to be a horizontal line. Right? So if B is 3 above, B prime is 3 below. If A is 1, 2, 3, 4, 5, 6, 7 above, A prime is 1, 2, 3, 4, 5, 6, 7 below. It goes off 1, it's okay. If C is 3 above, C prime is 3 below. Connect your dots, make sure you have an isometry. If I folded on this line, this is true for every reflection, if I folded on the reflecting line, I would end up with the shapes laying right on top of each other, point for point. Okay, that's one way you can know that you're doing a reflection correctly. All right, so let's look at two more examples of different reflecting lines. The line y equals x. This is a really important line in mathematics. If you don't know how to graph it, let's go ahead and make a few points. It says that the y equals the x. So if the y is 1, what will the x be? 1. If the y is 3, what will the x be? 3. If the y is 0, what will the x be? 0. Same all the way through. The x and the y are equal. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. -1, -1, etc. all the way across the graph. That is the line y equals x. Okay? Now, if I folded on this line, this shape would end up over here. Okay? So if you're going to count, there's something a little odd you have to pay attention to. If I'm going to count to graph B, I'm going to count either horizontal or vertical. It doesn't matter. I'm going to go ahead and count vertically. I'm going to count 1, 2, 3, 4, 5, and then I have to turn 90 degrees to count 1, 2, 3, 4, 5. Okay, this would be my B prime. So for A, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. A prime. And for C, I don't know which way to count. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. C prime. But it seems like there must be an easier way. That's where we turn to our rule. The rule for reflecting across the line y equals x is the A and the B, x and the y, trade places. So if I were to list point A as 1, 2, 2, -5, A prime, trade places, -5, 2. If I were to look at B as 1, 2, 3, 4, -1, the rule says that B prime, trade places, and C, if my original is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, so 6, -7, my rule says that C prime is -7, 6. That rule is awesome. That might be the rule I really want to make sure you try to memorize. Great. This is almost the same, but this time we're reflecting across the line y equals -x. Okay? So if let's look at the line. Y equals -x. So we're going to look at the x and the y. If the y is 1, the x is -1. If the y is 3, the x is -3. If the y is -3, the x is +3. Cool. Okay, so let's graph that. First, let's see. -1, 1 is going to be on the diagonal, but going the other direction. Okay. The rule, let's just go ahead and use the rule for reflecting now that we can see how good the rules are. So point A is 1, 2, 3, -3, -1. The rule says that A prime, they both trade and they both change sign. So I'm going to trade places and change signs. So instead of -3, -1, I'm going to have +1, +3. That's my A prime. B, I've got 0, 2, 3, -5. B prime, trade places, change sign, +5, 0. 1, 2, 3, 4, 5, 0. That's good.